What's up, Math 6 students? You guys ready to do this? I'm so ready to do this. I'm so ready to do this that my technology is not working. Oh, it's working now! 7.5, writing and graphing inequalities, which means that we have two quantities which are not equal. And our essential question is, how do I represent the solution set? Oh, this thing works so well. Represent the solution set of an inequality on a graph. Oh, I love this technology. It's working so well. All right. Okay, how would I represent the solution set of an inequality on a graph? And just to give you a quick introduction, a variable like x represents a number that we do not know, right? If I say x is greater than 5, well, x can be lots of numbers. Can x be equal to 10? And the answer is yes. Can x be equal to 6? And the answer is yes. In other words, there are lots and lots and lots and lots of numbers that will make this inequality true. So our goal today will be to be how we represent all of these solutions on a graph. Before we get there, we're going to go ahead and read through the key idea here. And the key idea is, an inequality is a mathematical sentence that compares expressions. So are they greater than, equal to, less than? It contains the symbols less than, looks like an L. Less than or equal to, looks like the L with the little line underneath. That means it could be equal to as well. Greater than, and greater than or equal to. So the or equal to are these lines underneath. To write an inequality, look for the following phrases to determine where to place the inequality symbol. Okay, inequality symbols, here are the symbols. See how it looks like an L? I'll even show you. If you want to put this into your own notes, you can do it. This looks like less. Oh, it's so hard to use this. Oh, it's not working. Hold on, let's see if I can get it to work. It kind of works. There we go. Okay, looks like the less than. Okay, you might see the phrase is less than, is fewer than. For greater than, is more than. So these words fewer and more can indicate an inequality. Is less than or equal to, makes sense. Is at most. It means it can be up to this value, but it can also be less. This left side can be less than that value. Is no more than, this is no more than this right side value. Is greater than or equal to, is at least, that means this thing never gets below this number that's over here. Is no less than, that means this number never gets below this number off to the right. Okay, so let's go down to our first row. And the first row says, what is a solution of an inequality or to an inequality? A solution of an inequality is a value that makes the inequality, I bet you already know it, true. Just like the example we just did, where x could be 10 or x could be 6, it makes the inequality x is greater than 5 true. An inequality can have more than one solution. The set of all solutions of an inequality is called the solution set. And that helps us understand that essential question. Solution set. Thank you guys for your patience while I write. This thing doesn't work all that well, but we're gonna make do. Okay, how can we check? The question over here is, how can we check if a value is a solution? Okay, we'll see these directions. Tell whether the given value is a solution of the inequality. Okay, here's the inequality symbol. Hopefully you know that's greater than. X plus 1 is greater than 7. Can x be equal to 8? Well, if x and 8 are the same thing, that means we could substitute 8 in for x. So I'm going to put an 8 where x was, plus 1, and we're checking if that's greater than 7. 8 plus 1 evaluated using order of operations. You get 9 is greater than 7. Is that true? It's true. So x equals 8 is a solution. So x equals 8 is a solution. And I could add to the inequality x plus 1 is greater than 7, but we'll just stop there for now since I don't have that much time on this video. To check if a number is a solution to an inequality, what was that word? Started with S. When the teacher's not there, you have a different teacher. You substitute. You put another value that's equal to that variable in its place. Substitute the number into the blank, into the variable, to see if the number makes the inequality true. And I can hear you answering those questions, which is great. Good job, everybody. Please pause and go back if you get stuck, and you can go over these as many times as you want, and it can help you get through any problems that are like this. Okay, now, how do you write an inequality and graph it? Okay, now we're really getting to the essential question here. Write the word sentence as an inequality, then graph the inequality. You know, it's interesting. The word inequality means not equal to, so it's not an equation. So we should be looking for words that tell us that we have two quantities that are not equal. A number, which of course always refers to a variable, and number C is less than -4. Now, if you go up to the key idea that's above, you probably remember that C is, well, less than. That starts with L, so it looks like a little L right here, less than -4. So we've now written this word sentence as an inequality. Now we have to graph it. Well, graphing it, how are we going to do that? Here's how we're going to do that. This number that's here, -4, we're going to put in the middle. And hopefully you remember the number that's to its right would be -3, not -5. We're in the negatives after all. As you go to the left, the absolute value is increasing. -5, -6. This is -2. Okay. Now, let's think about what's happening here. What values could C be? What values could C be? Could C be -6? Is -6 less than -4? Does that means -6 is to the left of -4? It is. So this would be a solution. So I'm going to put a little dot where there's a solution. Okay? How about -5? Would -5 be less than -4? Well, it's to the left, so -5 would be less than -4. What about -5.5? Would that be less than -4? Well, yeah, sure, of course it would. How about -4.75? Would that be a solution? Yeah. Ugh, it's going to take me forever going through all of these values. So what if instead we just represented them with a line that just goes to the left? All these numbers are going to make that inequality true. All of them. They're all going to make it true. Right up until what number? Well, what about -4 itself? Is -4 less than -4? The answer is no. They're equal, but not less than. So what we need to show that this number is not included in the solution set. All these numbers are solutions, but this number is not. So we do that with what we call an open dot. The open dot says -4 does not make this true. -4 is not less than -4. But everything to the left of -4, everything that's less than -4 does. So we use an open dot to show that. So we'll get to the next question. We just want to review what we've done so far by going over here. The graph of an, what is this? This is the graph of an, oh, that's right, this is an inequality. The graph of an inequality shows blank possible values of the variable that make the equation true. Well, which values does it show? It shows all of them. It shows all of the values that make this inequality true. So we're going to put true here. This is the solution set. And what kind of dot did we use here? We used an open dot on a number line to show that the value blank included in the solution. To show that the value is not, that the value is not included in the solution. Okay, Now we're going to move on to the next question, and to do that, I'm going to have to scroll down a little bit here. So let me do that. Okay. A number k plus 5 is greater than or equal to 8. A number k plus 5, and I don't know if you guys remember all the words that mean equals, but remember how is greater than or equal to, greater than or equal to, greater than or equal to 8. Okay, the or equal to, I actually said is, that was wrong. This is not, we're not doing equations right now. Greater than means you have an inequality, or equal to means we add this line underneath. The greater than is this, and the equal to is this line underneath it. Okay, k plus 5 is greater than or equal to 8. K plus 5 is greater than or equal to 8. Well, I could put 8 here, but we can't because we have to think of the numbers that k can be. Could k be 5? Is 5 plus 5 greater than or equal to 8? Yeah, because 5 plus 5 is 10. Now let's go down. What's 4 plus 5? That's 9. Is that greater than or equal to 8? Sure is. How about 3 plus 5? Is that greater than or equal to 8? It is. It's not greater than, but it's equal to. How about 2? What's 2 plus 5? That's 7. Is 7 greater than or equal to 8? No. So it looks like 3 is our important value here. 2, 1, 4, 5. I know during class I always say to number every other one, but we'll just do every single one here because we seem to have the space. Does 3 make this true? 3 plus 5. Is that greater than 8? No. Is it or equal to 8? Yes. So I'm going to put a red dot on 3 because that's so far as making it true. How about 4? 4 plus 5 is 9. Is that greater than or equal to 8? Yep. That is 2. What about 5? 5 plus 5 is 10. Is that? Oh, yeah, that is 2. And all of the rational numbers that are in between. That means all of the fractions and decimals in between are also included. But look at the difference from the last one. Instead of an open dot, because 3 makes this true, we're going to make this a closed dot. It says 3 is part of the solution set, but everything to the left of 3, everything that's less than 3 is not. So we use a closed dot on the number line to show that the value is included in the solution. And you can kind of think of this as an arrow. As long as the variable is on the left side, and I should have said that. Variable on left. Variable on left, then the arrow, here it is, points in the direction of all values that make the inequality true. Perfect. Okay, I have a limit on how long my videos can be, so I have to stop this video. I'll make a second video to cover the last example.